Hello student, welcome to my channel VK Voice. So today we are going to discuss more concepts of sound. So first concept which I am going to discuss with you today is free oscillation or free vibration. What is free oscillation or free vibration? I will demonstrate to you. And I am taking this, you are having, suppose this body is there, this body is here. And if I displace this body from its mean position and I just remove it, I am not applying the force now. It is vibrating with free vibration. Now, what is the definition of free vibration? Free vibration means when a body vibrate without the external force, in the absence of external force. So this type of vibration is known as free vibration, and the frequency which is there during the free vibration is known as natural frequency. Natural frequency depend upon size of the body, shape of the body. Keep it in your mind. Natural frequency depend upon the size and shape of the body. Now during the free vibration, body move with the constant frequency and constant amplitude. Now what are the examples of free vibration? First example is a example of tuning fork. When you strike the stem of the tuning fork on the rubber pad, then the prong of the tuning fork start vibrating. So this vibration is a free vibration, but the tuning fork is having a single frequency, so the vibration produced is also having single frequency. So this vibration is also known as pure note. So what is pure note? Pure note is a vibration or oscillation which is having the single frequency only. The next vibration, the next thing which is there, example is the, as I have shown you, the motion of the bob of simple pendulum. That is also a example of free oscillation. Now what is the frequency in case of bob or the simple pendulum? The frequency is given by the formula F is equal to 1 upon 2 pi under the root L upon G. That means frequency depend upon the length of the string and acceleration due to gravity. Two factors are there on which the free oscillation of a simple pendulum depend is length and acceleration due to gravity. Now if you are having, suppose, a pendulum whose length is 1 meter, in that case the frequency of that will be 0.5 hertz. This is there. So one example is there. Next example of free oscillation is when you are having, suppose a guitar or a sitar, stringed instrument you are having, and you pluck the wire or the string of that instrument. In that case, the vibration produced in that string instrument is also an example of the free vibration. And the frequency of that wire depend upon certain factors. And what are the certain factors? The example is, the formula is 1 upon 2L under the root T upon pi R square D, where L is the length of the string, T is the tension in the string, R is the radius of the string, and D is the density of the material of the string. So on what factor the frequency of a stringed instrument depend? It depend upon all these factors. Number 1, length. Number 2, tension. Number 3, radius of the string. And last one is the density of the string. So based upon this, the question can be asked: if the length is doubled, if the length change, how the frequency will vary? If you increase the length, what will happen to the frequency? If you increase the tension, what will happen to the frequency? All these type of question can be solved if you know this formula. Since you can see, if I will increase the length, frequency will decrease. If I will decrease the length, frequency will increase. Similarly, there is a direct relation between frequency and the tension. If I increase the tension, frequency will also increase. Inverse relation between the radius of the wire or the string. If I increase the radius, or you can say if I increase the thickness of the wire, in that case what will happen? R will be more, frequency will be less. Thicker is the wire, lesser is the frequency. Thinner is the wire, more is the frequency. So this type of question can also be asked, so keep it in your mind. That will be very beneficial for you in the examination. That type of question can be asked. Now one more example is there, when you just pluck a thread which is tied to one end. Suppose you are having a thread, like suppose you are having a string which is attached to the 2 points. 2 ends are attached to some rigid supports, and if you pluck it in the upward direction, then that case what happens? The string vibrate up and down. So this is also an example of free oscillation. Now one more thing, keep it in mind. If I pluck this string in the middle, in that case the vibration will be like this. Vibration will be like this. You will be having only single loop, and the frequency is F, and this is also known as principal frequency. But if I just pluck this wire from the 1/4 of the length, in that case what will happen? I will be having 2 loops like this. You will be having 2F frequency. Here I have plucked from 1/4 of the string, and if I pluck the same string by the length 1/6, in that case I will be having 3 loops like this. In that case I will be having 3 loops. So the frequency will be 3F. Now here you are having 2F. Here you are having 3F. This is called first subsidiary. First subsidiary. 2F first subsidiary, 3F second subsidiary. So you are having the frequency in the ratio of 1:2:3. You are having the frequency in the ratio of 1:2:3. And the wavelength of this will be, if the length of this thread or the string is L, in that case the wavelength will be like there. Here you will be having the wavelength 2L. Here you will be having the wavelength 2L/2. Here you will be having the wavelength 2L/3. That means the ratio of the wavelength will be 3:2:1. In this case you will be having the ratio 3:2. So this is the wavelength, this is the ratio of the wavelength, and this is the ratio of the frequency. So you should know what is the first subsidiary, what is the second subsidiary, how it can be attained, what will happen if I pluck the string from the middle, what will happen if I pluck this string from the 1/4 of the length, and if I pluck the string from the 1/6 of the original length. So all these things you just keep it in your mind. Next example of free oscillation is when you are having a flute and you just vibrate the air column inside that flute. In that case also air also vibrate with the free oscillation. And the ratio, if you are having open and suppose you are having an organ pipe, and this organ pipe is open from both sides, in that case the ratio of the frequencies will be 1:2:3 and so on. But if it is a organ pipe which is closed from one end, in that case the ratio will be 1:3:5. That means in odd multiples you will be having the ratio of the frequencies. So this is there. So keep it in mind. What is the ratios? This type of question can also be asked. Now next example of free oscillation is you are having suppose piano. When you just having piano, in piano also you are having the free oscillation. All these things are the example of free oscillation. So keep it in your mind. Next thing which I am going to discuss with you is the nature of free oscillation. What are there in free oscillation, that I am going to discuss with you. Now the nature is what happen, these type of oscillation will not takes place in the medium. If there is a medium, in that case you will not be having the free oscillation. Why? Because the medium will offer some resistive force, the frictional force which will oppose the motion. Some energy will be wasted in doing work against this resistive force, and this loss of energy, due to this loss of energy, the amplitude of the vibration goes on decreasing, and ultimately the motion ceases, the motion stops. So that, keep it in mind what happens if you will do all this experiment in the air or in any medium. In that case you will be not having the constant amplitude, but what will be happening, the amplitude will go on decreasing. Why the amplitude is decreasing? Because there is some loss of energy. Why there is a loss of energy? Because a resistance is offered by the medium. To overcome this resistive force, some work is done, and that work appear in the form of heat which is wasted to the surrounding, and hence ultimately what happens, in each vibration the body is losing some energy, amplitude goes on decreasing, and ultimately the body comes to rest. So the amplitude will not remain the constant, keep it in mind. So all these phenomena should take in vacuum. If these phenomena are taking in vacuum, only in that case the amplitude will remain same, otherwise the amplitude will not remain same, rather the amplitude will go on decreasing. And the oscillations which are having decreasing amplitude is known as damped oscillation. First of all, I will draw the graph for the free oscillation, and then I will draw the graph for the damped oscillation. So free oscillation, if I draw the graph, you are having, suppose here you are having displacement, and here you are having time. In that case what will happen, the amplitude will remain same, and frequency and amplitude will remain same, like this, like this. So amplitude will remain same. This is amplitude minus A plus A is the amplitude. Over here you can see the amplitude is keeping constant and frequency is also same. But if the amplitude, as I have told you, in case of damped oscillation, what happens, the amplitude goes on decreasing and ultimately the oscillation stop. So for damped oscillation I will again draw. So it will be like this, you can draw like this. Here you are having again displacement, here you are having time. So amplitude will decrease like this. And ultimately the vibration stops. So this is the graph for the displacement time graph for damped oscillation. Now what are the examples of damped oscillation? All those examples which I have discussed in case of free oscillation, if these are taken place in the medium, in that case that will be not a free, that will be an example of damped oscillation. For example, if I just move the bow in the air, again it will be ultimately, you can see ultimately what happens, the bow stops, it goes on, its amplitude goes on decreasing. In air it happens. So if I take these examples in air, in medium, in that case all examples which I have already discussed are an example of damped oscillation. One more example you can have, the example of when you are having, suppose, branch of tree and you just pluck it in the downward direction and then you release, then what happens, it moves up and down in the air and ultimately the branch comes to rest. So that is also an example of damped oscillation. Next topic which I am going to discuss with you is forced vibration. Now what is forced vibration? If I am having a body and if I apply periodic external force on it, then the vibration under the effect of periodic external force is called a free vibration. let me show you. If I am having, as I can show you like this, if I am having this, again suppose this is the pendulum, and if I apply this, if I just rotate it with the help of my hand, I am applying the periodic force on it. Again and again I am applying the force. So this type of vibration is known as forced vibration. Now here in this case, vibration, the amplitude of the vibration depend upon the frequency of the external force. Now the amplitude is not constant, it depend upon the frequency of external force. Now if the frequency of the external force is not equal to the natural frequency of the body, in that case the amplitude will be very small. But if the frequency of the external force is exactly equal to the natural frequency of the body, in that case the amplitude will be very large. So this phenomena is known as resonance, that I will discuss with you in detail in later section or in the next video. And the other examples of the forced vibration is like suppose you are having a tuning fork and you just strike it against the rubber pad and put it on the tabletop, then the tabletop will also start vibrating. Why? Due to the vibration of this tuning force. So the tuning fork is providing the periodic external force to the surface of the tabletop, and the tabletop is vibrating. This vibration is also an example of a forced vibration. And the vibration, the energy of this vibration which is produced in the tabletop is more. Why? Because the surface area of the tabletop is more, as the energy of the oscillation is also more. Now the next example of forced vibration is when you are having, suppose you are having a guitar and you just pluck the string of the guitar, then the air column in the hollow box will start vibrating. These are vibrating due to the vibration of the string. So string vibration is providing the external periodic force, due to which the air column is also vibrating. So this vibration is also an example of forced vibration. Similarly, if you are having any other, suppose you are having guitar or anything, so in that case also these are the example of forced vibration. So these are the example of forced vibration. Today I will just stop over here only, because you can see this is very humid atmosphere over here. I am just making effort to just make you, to get you a good marks in the examination. So if you see some sweating on my face, so it is due to only that, because it is very humid atmosphere over here. Thank you for watching my channel over here. I request you, please share, comment and subscribe my channel so that my effort don't go waste. Thank you.